All right, let's talk about right triangle trig. Skippity skippity. Okay, so right triangle trig. Let's say we have this right triangle. Okay, we have some angle theta. Hopefully we know by now how to label our sides. You know, our first side would be opposite or across from theta, so this would be the opposite side. We have our hypotenuse, which is always opposite the right angle. And our third side, which is adjacent to theta. Adjacent means next to. Hence why it's called the adjacent side, right? Then, now how do I get this little thing to appear? Oops, sorry if I'm making you dizzy. There it is. All right, so hopefully we know all of these beautiful things. This shouldn't be brand new to you. If it is, then lordy lordy. But you know, we know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and so on. We also know that we have that really cool thing that tells us, you know, a little cheat for it. It's a little acronym. What is that? Yes, that is so, well, this is neat. Toa. I don't know why, but this reminds me of that game where you have that little worm trying to eat all those things. Maybe you know what I'm talking about. Maybe you don't. Okay, anyway, let's go to an example. All right. Oh gosh, gotta get rid of this. Okay, so given that secant of theta is 6/5, find the remaining trig functions. So my hint to you is to draw a right triangle, use this information, find the third side, then state the rest. You can do this. Go ahead. All right, time to check your answers. So hopefully you drew that right triangle. Found out that that third side, which ends up being the opposite side, is the square root of 11. Using this information, we can find the remaining 5 trig functions. So cosine of theta is 5, 6, sine of theta is square root of 11 over 6, and so on. Notice that over here I had, you know, square root of 11 in both of my denominators. If you left your answers as this, that's fine. Did you hear me? That's okay. You don't have to rationalize the denominator. But if you did rationalize the denominator, this is what you should have had. All right. So in this example, how do you know that theta is not a right angle? How did I know that not to choose this angle, theta? Write your answer. In conclusion, so to the ka to the toa.